Hello everyone. Today we are going to see the questions from the mathematical economics part, which was asked for the recently conducted NTA NET exam June 2020. There are around 11 questions from this area. Let's see in detail each question. Now let's move on to the first question. So in this question we can see that the total revenue function is given. The total revenue is equal to 1400q minus 6q square, and the total cost function is given, which is 1500 plus 80q, and the quantity or q is given, which is equal to 100 units. Now we need to look at the option and pick up or choose the correct options. So see, in the option we can see marginal revenue and marginal cost are given. So the first option is MR greater than MC, second one MC equal to 80, third one MR less than MC, and fourth one MR equal to MC. So in order to see which of these options are correct, we need to find the value of MR and MC. So the total revenue function is given. So now you can find marginal revenue. We know that differentiating the total revenue you get marginal revenue, and differentiating the total cost we get marginal cost. Now let's do that. So we have total revenue equal to 1400q minus 6q square. So marginal revenue is equal to differentiating the cost function, we get 1400 minus 12q, and we know that q is equal to 100. So substituting that we get 1400 minus 12 into 100, which is 1400 minus 1200, which is equal to 200. So marginal revenue is equal to 200. Now let's find the value of marginal cost. So marginal cost, we are differentiating the total cost, so we get 80. We know that when you differentiate a constant, differentiation of a constant is equal to 0. So 1500 is cancelled out, rest it's 80q, so we get the answer 80. Okay. Now we have the values for marginal revenue and marginal cost. So you can clearly see that marginal revenue is greater than marginal cost, because marginal revenue is equal to 200 and marginal cost is equal to 80. So marginal revenue is greater than marginal cost. Now let's look at the options. So the first option is MR greater than MC. So that is true. Now the second option, MC equal to 80. Yes, again we can see that MC is equal to 80. So that option is also true. Now the third option, which is MR less than MC. So MR less than MC, no. So that is false. And the fourth option, MR equal to MC, definitely MR is not equal to MC. So the answer is option A and B. So I will illustrate it once more. So we know that the total revenue is equal to 1400q minus 6q square, and total cost is equal to 1500 plus 80q. So we need to find marginal revenue and marginal cost. Differentiating the total revenue, we get marginal revenue, and differentiating the total cost, we get marginal cost. So first we are finding the marginal revenue, which is 1400 minus 12q, which is differentiating this function, we get 1400 minus 12q, and total cost, differentiating 1500 plus 80q, we know that 1500 is a constant, differentiation of a constant is equal to 0. So the rest we get 80q, differentiating 80q we get 80. So we need not substitute the value of q here, because we have already got a constant here. Okay. So MC, we got the answer for marginal cost directly as equal to 80. Now we have the values for MR and MC, and looking at the options we can say that option A and option B are true. Now let us look at the second question. In the second question, a production function is given, which is Q is equal to A L raised to alpha K raised to beta, and we have 4 options given. So the first option is A denotes the managerial efficiency. Second option is if alpha plus beta is greater than 1, which means that there is increasing returns to scale. And the third option is marginal rate of technical substitution of L for K, labor for capital, is equal to beta K by alpha L. And the fourth option is marginal productivity of capital is equal to beta Q by K. So out of these 4 options, we need to choose which of these are true. So now let us look at each option in detail. First one, A denotes a managerial efficiency. Okay, so when you look at this production function, which is Q is equal to A L raised to alpha K raised to beta, we know that this is if alpha plus beta is equal to 1, then we know that it is a Cobb-Dufflas production function. Okay. So if you look at this production function, we can see that A denotes the technology, or we can call it as the managerial efficiency. Both are same. So option first option is true. Okay. Now let us look at the second option. So suppose if alpha plus beta is greater than 1. So if alpha plus beta is greater than 1, it is increasing returns to scale. Yes, we know that if alpha plus beta is equal to 1, it is constant returns to scale. If alpha plus beta less than 1, decreasing returns to scale, and if alpha plus beta is greater than 1, it is increasing return to scale. So option B is also true. Now the third option is marginal rate of technical substitution of L for K, that is labor for capital, is beta K by alpha L. So we need to, in order to say if this option is true or false, we need to find marginal rate of technical substitution, and the fourth one is marginal productivity of capital. Okay. So we need to find marginal rate of technical substitution and marginal productivity of capital and labor. Okay. So the equation for marginal rate of technical substitution is technical substitution L for K is MPL by MBK. Okay. So in order to find marginal productivity of labor, we need to differentiate, or partial differentiation is used here, because we need to find the change in the output with respect to labor alone, marginal productivity of labor. So if there is any change in the quantity of labor, what is the change in output? Okay. So in order to find MPL, we differentiate this function with respect to labor alone. Okay, so differentiating this with respect to labor alone, we get A alpha L alpha minus 1 K raised to beta. Okay, so this can be written as A alpha L raised to alpha K raised to beta by L. Okay. So A alpha L raised to alpha K raised. So, okay, look at this. A L raised to alpha K raised to beta. A L raised to alpha K raised to beta. That is again Q. So we can write this as alpha Q by L. Clear? Now we need to find marginal productivity of capital. So the same procedure is used. We are partially differentiating Q with respect to capital. So we get A beta K raised to beta minus 1 L raised to alpha. Okay. So this can be written as A beta K raised to beta L raised to alpha by k. So again if you look at this, A L raised to alpha, k raised to beta, which is q. So you can write it as beta q by k. Okay. So we now have the answer for MPL and MPK. Now we need to substitute this here. Before that, let us look at the fourth option. Marginal productivity of capital is equal to beta q by k. So look here, beta q by k. So we can say that the fourth option is also true. Now let us look at the third option, which is marginal rate of technical substitution. Now we will substitute the value for MPL and MPK here. Value for MPL is alpha q by L whole divided by value for MPK, which is beta q by k. Okay. Now cancelling this out, we get alpha k by beta L. Alpha k by beta L. See, cancelling q and then taking the reciprocating it and then multiplying it here, we get alpha k by beta L. See, look at here. Here the answer is beta k by alpha L. So that is not true. Okay, I will explain it once more. We have a production function given here, q equal to A L raised to alpha k raised to beta. Okay. So now we have four options. The first option is A denotes a managerial efficiency. Yes, that is true. A denotes managerial efficiency. Second option, if alpha plus beta is greater than 1, then it is increasing returns to scale. Yes. When you add this alpha and beta, if it is greater than 1, then it is increasing returns to scale. Again that option is true. Then the third one is marginal rate of technical substitution of L for k. So marginal rate of technical substitution of Lk is equal to MPL by MPK. So we need to find marginal productivity of labor and marginal productivity of capital. Okay. So we need to partially differentiate this function with respect to labor and with respect to capital in order to find the marginal productivity of labor and capital. Okay. After finding MPL and MPK and substituting the value for MPL and MPK in this equation, we get the answer alpha k by beta L. Alpha k by beta L. Okay, so which is not the answer. So this option C is wrong. Now looking at the option D, which is marginal productivity of capital, we get beta q by k. Yes, while solving out this marginal productivity of capital, we have got the same answer, which is beta q by k. So option A, B and D are true and C is not true. The third question is a match the following question. So now let us look at the question. So we have certain functions given here and equation or not the general equation, but equation is given here. Now we need to relate the RHS and the LHS side. So we can look at the LHS side first. So we have linear function, quadratic function, exponential function and power function. Now we need to see among these four options which is a linear function, which is a quadratic function, which is an exponential function, which is a power function. So in order to understand that, first we need to see the general equation for these functions. Okay. So now let's look at the general equation for linear function. We know that a linear function is written as y is equal to mx plus c. So when you say a linear function, we know that when you draw the graph of this particular equation, we get a straight line. So y is equal to mx plus c. Now let us look here. Okay. So when you look here, let us see which equation is represented in this form, y equal to mx plus c. So the first one, y is equal to 3x square plus 2x plus 9 So it is not represented in this form. Now the second one, which is y equal to 5x cube, no. Third one, y equal to 3e raised to 2x, no. And the fourth one, y equal to 5x plus 3, yes. Y equal to mx plus c, y equal to 5x plus 3. So this is the equation for, or equation which represents a linear function. So the first one is matching with the fourth option. Now the second one is quadratic function. Okay. Now let us see the general equation for quadratic function. So the general equation for quadratic function is y is equal to ax square plus bx plus c. So here if you look here, the maximum power is 2 here. In a quadratic function, the maximum power of x would be 2. So look here. In these options, see the first option. First option is y equal to 3x square plus 2x plus 9. So it is matching with this general equation. So this one. Now the third one, exponential function. Okay. So for an exponential function, the equation is, general equation is y is equal to a b raised to x. So here the exponent is x. Y is equal to a b raised to x. Now let us look here. Okay, for the third option, the exponent is 2x. So 3e raised to 2x. So the answer for exponential function is y e raised to 2x. And the fourth one, which is the power function. So power function is represented as ax raised to b, where b represents a real number, any real number. Okay. Okay, so this one is y is equal to 5x cube. See. So hope the options are clear now. When you get a question like this, like to match linear function, quadratic function, exponential and power function, we need to keep in mind the general equation for these particular functions. If you know the general equations of these functions, it is easy to match it. So this is the answer for this question. The next question is regarding cross price elasticity. Okay. So we know that this cross elasticity connects the demand for a good and a price of another good. These two goods can be either substitutes or complements. Okay. So the question goes like this. Cross price elasticity of demand of metro rides is equal to 0.8. Total ridership per day is given, which is 1.5 lakh if price of best ride rises by 5%. Okay, if the price of best ride rises by 5%, change in total metro rides. We need to find the change in total metro rides. Here they connect the demand of metro rides and price of best ride. Okay. So the two goods which they are connecting is, one is best ride and the another one is metro ride. So they are connecting the demand for metro ride with the price of best ride. Okay. So we know that this cross elasticity connects the demand for a good and a price of another good. These two goods can be either substitutes or complements. Okay. So the question goes like this. Cross price elasticity of demand of metro rides is equal to 0.8. Total ridership per day is given, which is 1.5 lakh if price of best ride rises by 5%. Okay, if the price of best ride rises by 5%, change in total metro rides. We need to find the change in total metro rides. Here they connect the demand of metro rides and price of best ride. Okay. So the two goods which they are connecting is, one is best ride and the another one is metro ride. So they are connecting the demand for metro ride with the price of best ride. Okay. So we know that the equation for cross price elasticity is delta qx by delta py into Py by Qx. Okay. So, which is change in the quantity demanded for metro rides by change in the price of bus ride into price of the bus ride by quantity demanded of the metro rides. Okay. Otherwise, this formula can be written as percentage change in quantity demanded of good A by percentage change in price of good B. Here, good A is the metro ride and good B is the bus ride. Okay. So, we can see that from the question, the cross price elasticity is given, which is 0.8. So, 0.8 is equal to percentage change in quantity demanded of good A. So, no, that is not given. So, let us represent it as X, and percentage change in price of good B. Yes, price of bus ride rises by 5%. So, we know that it is 5%. We need to find X. So, X is equal to 0.8 into 5, which is equal to 4%. Okay. So, now the question is, we need to find the change in total metro rides. Okay. So, in order to find the change in total metro rides, in the question it is given total ridership per day is 1.5 lakh. So, the change in metro rides is 4% of 1.5 lakh. So, we can find that 4 by 100 into 1.5 lakh, which is 6,000. Okay. So, 4 by 100 into 1.5 lakh, when you solve this you get 6,000. So, that is the answer. So, which is option C. Clear? Here we the cross elasticity of demand of metro rides is given, which is 0.8, and the total ridership per day is given 1.5 lakh. And the price of bus ride rises by 5%. So, all the variables which we needed are given in the question. We just need to substitute it in the equation. We know that the cross price elasticity of demand is equal to percentage change in quantity demand of good A by percentage change in price of good B. Substituting in this, we get percentage change in quantity of good A, which is 4%. Now, in order to find the change in total metro rides, it is 4 by 100 into 1.5 lakh. So, you get the answer as 6,000, which is option C. Now, this question is asked from the game theory. So, here we have a matrix given and we have player A and player B. The question was to find the solution for this matrix. So, basically by solution you need to from the options we can see that we need to find the value of the game and the best strategy for player A and player B. Okay. So, when you say the value of the game, it is a saddle point. Okay. So, when we have two players, so when you say the value of the game, we need to find the saddle point, and the saddle point is a point where maxi-min is equal to mini-max. Okay. So, maxi-min is equal to mini-max, which is player A and player B follows a particular strategy. So, this is a two-player game. So, we have two players, player A and player B. So, we assume that player A follows a maxi-min strategy, that is maximizing the minimum gains. That is a strategy followed by player A, and player B follows a mini-max strategy, that is minimizing the maximum loss. Okay, I will write it here, maxi-min, which is maximizing the minimum gains. and minimax, which is minimizing the maximum loss. Okay. So, these are the strategies followed by player A and player B. Now, player A, we know that it follows maxi-min strategy, that is maximizing the minimum gains, and we read this matrix, or we read the player A row wise. Okay. So, player A has 3 rows. Okay. So, now we need to find the value of each row, that is maximizing the minimum gains. So, write the minimum value of these each row. So, here we have 2, here we have -5, and here we have -2. Okay. Maximizing the minimum values. Okay. Now, for player B, we are reading it column wise, and from each column we need to write the maximum values. Okay. So, here 2, 6 and 2, 6 and 2. Yes. So, from here again we can see that minimizing the maximum loss. Okay, minimizing the maximum loss. So, now we need to take the maximum value, or sorry, we need to take the minimum value from this. So, the minimum value is 2 here, and from here we need to take the maximum value from these minimum values. So, here the maximum value is 2. Okay. So, we can see that this minimax and max-min, these two values becomes equal at the point 2. Now, look at the matrix. We have, see, we have 3 values which denotes 2. So, all these are considered as the best strategy, are considered as best strategies for player A and B. So, this A1 B1, A1 B3 and A3 B1, these 3 are the best strategies for player A and player B. Okay. Now, let us look at the options. So, the saddle point or the value of the game is 2, that is confirmed for sure, because the maximin is equal to minimax at point 2. Now, we need to look at the best strategies. So, I have told you that we have 3 best strategies here, which is A1 B1. Okay, A1 B1, next one is A1 B3. So, yes, A1 B3, and the third one is A3 B1, A3 B1. So, the answer is option 2. I will just explain it once more. This question is asked from game theory. We need to find the value of the game. So, here we have 2 players, player A and B. So, in order to find the value of the game, we need to find the saddle point. So, player A follows maximin strategy and player B follows minimax strategy. Maximin means maximizing the minimum gains, and minimax means minimizing the maximum loss. Okay. By taking or considering these 2 strategies, for player A, we are reading it row wise. So, taking the values from each rows, we get 2, -5 and -2, and for player B, we are reading it column wise. So, taking the values from each column, we get 2, 6 and 2, and see, and the saddle point is 2 because we are maximizing the minimum values. So, taking the maximum from this, we get 2, and here minimizing the maximum values. So, taking the minimum value from this, you get 2. So the saddle point is 2 and we have 3 best strategies here, which is A1 B1, A1 B3 and A3 B1. So the answer for this question is option 2. This question is from the cost function. So in this question we have the total cost given, which is q cube minus 10q square plus 60q, and we need to find minimum average cost and the level of output. Okay, so we need to find the minimum average cost and the level of output at which the average cost is minimum. So we have the options given. So the minimum average cost and the corresponding output is given as options. Now let's solve this. So we know that when you draw this graph, the marginal cost cuts the average cost at its minimum point. Okay, the marginal cost cuts the average cost at its minimum point. So at that point MC is equal to AC, marginal cost will be equal to AC. In this question the total cost is given. So from that we can find the average cost and the marginal cost. Okay, so average cost is equal to TC by Q. So dividing this equation by Q, we get the average cost. So see, average cost is equal to dividing throughout this equation by Q, you get Q square minus 10Q plus 60. So this is the average cost. Now marginal cost is differentiating this equation, we get the marginal cost. So differentiating this, we get marginal cost is equal to 3q square minus 20q plus 60. Okay. So we have AC and MC. Now we need to equate these two. So we will write when AC equal to MC, equating these two equation, we get q square minus 10q plus 60 is equal to 3q square minus 20q plus 60. Okay. So cancelling out these two, the 60 and 60, and taking q square to that side, which is 3q square minus q square is equal to 2q square, and taking this 20q here, we get 20 minus 10q, which is 10q. So we get 10q is equal to 2q square. So cancelling this q, we get q equal to 10 by 2, which is equal to 5. Okay. So q equal to 5. Now look at these options, q equal to 1, q equal to 1. So clearly we can rule out option C and D. Now we have a confusion between option A and B. So by substituting the value of q in the AC, we get the answer for AC. So see here, AC is equal to 5 square, which is 25 minus 50 plus 60. So we have 25 plus 10, which is equal to 35. So q is equal to 5 and AC equal to 35, which is option A. This is very simple question. We have the total cost function, total cost is given. We need to find the average, the AC, minimum point of AC, and the quantity at which the AC is equal to, AC will be minimum. Okay. So we know that marginal cost cuts average cost at its minimum point. So at that point AC equal to MC. Now equating AC and MC, we get the value of output is equal, output as 5, and substituting that value in the AC equation, we get the value of AC as 35. So, the option is answer A. Next one is an assertion reason type question. So, the assertion is a matrix is given, A is equal to 503 minus 102 101. So, determinant of A is equal to 0. So, since all elements in column 2 are 0, that is assertion. So, since all elements in column 2 are 0. Reason, Laplace expansion permits evaluation of a determinant along any row or column. Okay. So, assertion says that determinant A is equal to 0 since all elements in column 2 are 0. Yes, it is true. You can see that. So, if you expand this particular matrix using this column 2, we can see that we get the determinant 0, or using any row or column. See, take the first row. If you expand it with the first row, you get determinant A is equal to 0. So, that is the first statement. And the second statement states Laplace expansion permits evaluation of a determinant along any row or column. That is also true. So, Laplace expansion permits evaluation of a determinant. We can find the determinant of this particular 3 into 3 matrix using any row or column. So, you can use this first row, second row, third row, or first column, second column, third column. So, that is also true. So, assertion is true, reason is also true, and reason is the correct explanation of assertion. So, the answer is assertion and reason are true, and reason is the correct explanation of A. Next question is, we need to find the equilibrium level of income using the given set of data. So, let us see what is the data which is given in the question. So, we have C is equal to 50 plus 0.8 YD. C means consumption is equal to 50 plus 0.8 YD. YD is the disposable income. T is the tax, is equal to 20%. I is the investment, which is 100, and G is the government expenditure, which is 30. Okay, using this given set of data, we need to find the equilibrium level of income. So, we have 4 options given, which is 400, 300, 500 and 600. So, we know that the equation for finding the equilibrium level of income is equal to C plus I plus G plus Nx. But here this Nx is immaterial because there is no information given on export and import. Okay. So, we can just neglect this. Okay. Now, this YD is the disposable income. Okay. Here YD is the disposable income, and the equation for finding the disposable income is Y minus T, which is the income in hand minus tax. Okay, after deducting for the tax, what is the income you have in hand? That is the disposable income. So, YD is equal to Y minus 20 by 100. See, we know that 20% is the tax. So, to find the disposable income, we subtract 20% of Y from Y. So, Y minus 20 by 100 into Y, which is Y minus 0.2 Y is equal to 0.8 Y. So, we got the disposable income. Okay. Now, we will substitute this C, T, I and G in the original equation. So, Y is equal to C. C is 50 plus 0.8 YD, 50 plus 0.8 YD plus I is equal to 100 plus G is equal to 30. Okay. So, adding these three 100, 50 and 30, we get Y is equal to 180 plus 0.8 into YD. YD is 0.8 Y. Okay. So, we have Y is equal to 180 plus 8 into 8 64. So, 0.64 Y So taking this 0.64y to this side, we get 0.36y is equal to 180, or we will write it here, 0.36y is equal to 180. So we get y is equal to 180 by 0.36. So we have two decimal points here, so we multiply it with 100. So you get 18000 by 36. So 36 into 5 is 180. So you get 500. So the answer for this question is 500. So which is option 3. Okay. So I will just explain it once more. We need to find the equilibrium level of income using the given information. So we know that the general equation for finding the equilibrium income is y equal to c plus I plus d plus nx. Nx is immaterial here because there is no information given on export and import. So we substitute for the value of Cing. C we have 50 plus 0.8 yd, then I is equal to 100 and g is equal to 30. Then we are substituting the value for Ig and c in this general equation. Then we get y equal to 180 plus 0.8 into 0.8y. This is the disposable income. Disposable income, we find out disposable income using the equation y minus t, that is income minus tax. Okay, so tax is given as 20%, which is 20% of the income. So y minus 20 by 100 into y, which is equal to 0.8y. So substituting 0.8y here, we get y is equal to 180 plus 0.64y, and solving this we get y equal to 500, which is option 3. Next question, this is a very simple question. This question, production function is given, which is q is equal to 10 into L raised to 0.8 k raised to 0.2. We need to find the marginal productivity of labor and marginal productivity of capital. So we have 4 options given. From this option we have to choose the right answer. Okay. So first we will find the marginal productivity of labor. Okay. So the marginal productivity of labor, we have we have the total production function, which is 10 into L raised to 0.8 k raised to 0.2. So in order to find the marginal productivity of labor, we need to partially differentiate this equation with respect to labor. Okay. So which is 0.8 into 10 L raised to 0.8 minus 1, which is 0.2 k raised to 0.2. So this can be written as, which is equal to 8 into k by L raised to 0.2. Since it is L raised to minus 0.2, L comes in the denominator. So it is k by L raised to 0.2. Now marginal productivity of capital. So marginal productivity of capital is equal to 0.2 into 10 L raised to 0.8 k raised to 0.2 minus 1, which is minus 0.8. Okay. So again, since it's k raised to minus 0.8, k comes in the denominator. So we have 2 L by k raised to 0.8. Okay. So now let's look at the option. So MPL. So MPL is equal to 8 into k by L raised to 0.2. Okay. So option 1 is correct. Now we need to find MBK. So this is not the right option. See, it's 8 into k by L. Now MBK is equal to 2 into L by k. 2 into L by k raised to 0.8. So, option A and C are correct. A is MBL equal to 8 into K by L raised to 0.2 and MBK equal to 2 into L by K raised to 0.8. So, option A and C are correct. So, I will just explain it once more. We have a production function given. We need to find the marginal productivity of labor and marginal productivity of capital. We know that in order to find the marginal productivity of labor, we need to partially differentiate this equation with respect to labor, and in order to find the marginal productivity of capital, we need to partially differentiate with respect to capital. So, partially differentiating it with respect to labor and capital, we get 8 into K by L raised to 0.2 and 2 into L by K raised to 0.8. In this question, we need to find out the correct equation which represents national income identity, and we have 4 equations given. This is a very simple question. By looking at the options itself, we get the answer. So, we have the first option, which is y equal to C plus I plus X. X denotes imports minus exports, and y equal to C plus I plus G, sorry, not imports minus exports, it is export X minus M, exports minus imports. Okay. So, y is equal to C plus I plus G plus S. So, C is consumption, I is investment, G is government expenditure, S savings. So, you know that this is not the right equation. Then the third one, y equal to C plus I plus G plus X minus M. Yes, this is the equation for national income identity, that is consumption plus investment plus government expenditure plus exports minus imports. And the fourth option, y equal to C plus I plus G plus M, no, this is not the right answer. So, the answer is option C. This is the last question in this series. So, the question is, we need to find the valid objective function from these 4 problems as far as this linear programming is concerned. Okay. So, we know that in linear programming, we have a general format for writing or for expressing the objective function. Okay. So, now let us look at the option. So, here maximize Z is equal to 5x square y. So, we know that in linear programming, we do not use x square xy, we do not use these expressions to denote the general objective function. Okay. So, maximize Z equal to 5x square y is not the answer. Second one, maximize Z is equal to 3x plus 2y plus 8xy. Again see this xy. This expression, we do not use this expression when you represent a linear programming. And third one, maximize Z is equal to 2x square plus 3y square. See, the power of the function is 2. So, we do not use it. And the fourth one, maximize Z is equal to 5x plus 2y. Yes, this is the right equation, or this is the way we represent linear programming. So, the answer for this question is fourth one, maximize Z is equal to 5x plus 2y. Now, we have covered up all the questions that were asked from the mathematical economics part. So, please stay tuned to Applebee to watch more videos. Happy learning.